So here is our experimental setup. We have one buoy, we have a light, we've got our glass sample. It's sitting on some scrubbing pad, or you might call it a chucks or a Scotch-Brite or something. And I've got that there just to make sure that there's nothing about the bottom surface that's going to affect the results. Because I want to inspect the interaction between the still ball bearing here and the glass, not the bottom of the glass and whatever's underneath it. So this will soak up some of the impact, but it means that there's fewer variables involved, and I'll be doing all the testing on this same mat. So then we're going to drop the ball bearing onto the glass from increasing heights. Once we get up pretty high, we've got a pipe ready to guide it down, and then we'll keep dropping it from higher and higher heights until it breaks. And we also have a bee joining us, buzzing around the light up there. Okay, let's see how we go. 10 centimeters, 20 centimeters, 30 centimeters. Oh, we've got something. I should hold it in front of the camera. So that's the failure mode that I saw when I was hitting it with the hammer. Sort of crater kind of thing. Fortunately, I wasn't inspecting when I did the earlier drops, because I really didn't expect anything to happen. So let's drop on a different spot at 20. So that hit there. So we can see, and I can just feel it. So that's significantly less good than I had hoped. Oops. So I might go around and mark all these impact points with a permanent marker and then do a couple more tests. Just so we don't confuse the ones that we are making with the ones that we have made. Okay, so I've put circles on all the damage that we know about. I'm going to drop on an undamaged portion, and here's 20 centimeters again. So here's 20. Oops, that kind of glanced off the edge. Not super scientific with my release technique. Yeah, okay, so it does seem like 20 does reliably damage it.
But we want to break it.
We're trying to establish a baseline for different treatment systems to try to make the glass tougher. So this is the one that's been through 3 firings, and the middle one of those was only up to 400 in potassium nitrate bath. So let's try 10 a few times to confirm that that doesn't do the damage. 10 again, 10 again, 10 again. Nothing. I really should be measuring to the surface of the glass, because I might want to test a thicker piece later, but I can adjust my numbers accordingly. Okay, so 10 seems to be safe. Let's try from 15. So I'm seeing some marking on the surface. There we go, there's a little pit. Okay, so we know that 15, I don't think there's much of a meaningful difference in this testing methodology between 10 and 15, so I won't bother. What I do want to see is how it fails if it's really, really clobbered. So I'm going to do a drop from 50, 60, 70, okay, 80, there's 90 now. Oh, hey!
Shadow!
Okay, so 90 was enough to blast it straight in half. Okay, so, oh, look at that. That looks pretty. Careful.
That was clear snap.
Mm-hmm.
No sharp ones.
So,
That's nice.
yeah, that looks pretty cool.
I'm going to keep them.
No, I'm going to take lots of photos. But we can see, I don't know if it's clear in this camera or not, we can see like the layers of glass are still visible in there. We can see the sort of strata of the surface filth that was on the glass before it was fused together. Okay, so this is the window 2 that has had no potassium nitrate treatment done. Let's drop from 10, 15, 15 again, 15 a third time, 20, try 20 again. Oh, we got something. That same failure mode there. Third one on 20, nothing. Okay, so only one out of the 3 20s broken. 30. 40. We're getting consistent damage at 40. Let's go up to 60. That's a no for 60. 80.
Oh yeah, big one.
Oops, that's a 70. 90. 3 hits at 90. Okay, so the pipe is 1 metre long, give or take. Filth out of this filthy pipe. So let's go up to 120.
Get cracked.
Alright, we've got a crack at 120. So last time we cracked at 90 on the first try. So this isn't totally scientific because we're not controlling for like hitting an existing crater. Righto, so here's our results. So the ball weighed in at 28.15 grams. It was 19 millimeters diameter. I could probably work out the density, but I suspect it's probably just steel. So our results for glass window 1 showed that it started cracking much sooner. So it started cracking at the 15 centimeter mark, whereas window 2 started to crack at 20 but didn't reliably crack until we got up to 40. So it's not a huge difference. A bee on my foot. Some bees here. And it didn't fail completely until 120 centimeters. Whereas the first one failed completely the first drop at 90. So, you know, not a heap of high quality data because we weren't controlling for where the ball was hitting exactly, only the height it was dropping. So it could have failed because it hit a weak point like a previous chip. But the failure modes are different enough to be interesting. So this is window 1, so it was fired 3 times, and it cracked straight through, clean break, no mess, no fuss. It's got a really cool internal pattern. See if I can get the camera to focus on that. So you can see it's got lots of visible layers in there, bubbles, grit, filth and such. Whereas window 2 cracked much more messily. Now that just might be a factor of where it was hit, where the crack spread, but it's got much less internal grit. It's got bigger internal bubbles, however. Window 1 has lots of tiny bubbles, but window 2 has more contiguous bubbles. But yeah, it looks pretty cool, I think. It looks really nice getting the light in there and rocking it back and forth. The camera doesn't really do justice to it. We did blow this shard out of the middle of window 2. This is really bloody sharp. So it seems like fewer firings or no potassium nitrate treatment might give us a stronger result. And also the small crater failure mode, where the surface of the glass forms a crack with that kind of profile. So the ball came in and hit it on the top here, and it forms this kind of this kind of cone-shaped crack. But it peters out as this circle gets, because if you look at it from the top, you see a small crack on the surface, and then a bigger crack, that sort of where the end of that crack is deep in the glass. So this is on the surface, this is deep in the glass. Why am I drawing looking at the phone screen when I can just tilt my head slightly? Okay, so that's some good results. I'll go through the video and confirm that all my numbers line up, but it looks as though window 2 might have been stronger. It was slightly thicker, which probably helped. So this one, can't remember. So window 1 is 1427 at its thickest point, because it gets thinner towards the edge. And window 2 is 16.66. So it's slightly thicker, which probably explains a small portion of the apparent increased gross strength, but that doesn't explain the surface strength, which seems to be slightly tougher on this one than on this one. Okay, that's all for now.